All right, so in question number 6, we're going to be looking at how to factor quadratic binomials. We're going to be using the difference of squares method and also the concept of GCF, or greatest common factor. So the question reads, which expression is equivalent to 18x squared minus 50? So we have 4 options here. You can see that they're all factored, so the indication is that we are to factor this expression. Okay, so we have 18x squared minus 50. If you take a look at these numbers, it's not apparent that they are perfect squares. Whenever you're factoring, what you always want to do first is ask yourself, is there a greatest common factor that I can extract from the expression, the polynomial expression? It doesn't have to be a binomial. It could be a trinomial or polynomial with 4 terms. Okay? When you pull out the greatest common factor, it makes it much easier for you to factor the expression. So what we want to do now is we want to find the GCF of 18x squared and 50. Okay, we're going to break it down the entire process, and then we're going to highlight what the GCF is. So what we're going to do is proceed to decompose these two completely to reveal what their prime factors are, and then we can see which factors are common, extract those, combine them, and that will be the GCF. All right, so the first term is 18x squared. What we're going to do is decompose this completely, okay, using only prime factors. So what is the smallest prime that goes into 18? Start with 2. 2 goes into 18 because it's even, right? So you can take out 2. 2 goes into 18 9 times, right? And then what's the smallest prime factor that goes into 9? 2 doesn't go because 9 is odd. 3, absolutely, 3 goes into 9. How many times does 3 go into 9? It goes into 9 3 times. And then we can break up the x squared into x times x. So the decomposition of 18x squared into factors is 2 times 3 times 3 times x times x. Okay? What's the beauty of this? Well, hold on, we're going to go over that in a second. Now let's look at the second term, 50. We're going to decompose this completely into a product of primes. 50 is even, so 2, the first prime number goes into that. 2 goes into all even numbers, 25 times. 3 doesn't go. 4, no, because 2 doesn't go. 25. 5 goes here because it ends in 5. All right. The divisibility by 3, you just have to add the digits. 2 plus 5 is 7. 3 doesn't go into the sum, which is 7, so 3 doesn't go into 25. Okay, but 5 goes. So take out 5. 5 goes into 25 5 times. The prime factor decomposition of 50 is 2 times 5 times 5. All right, remember, we want to see if we can extract the GCF. So let's go ahead and put the factored forms back underneath each term. The decomposed form of 18x squared is 2 times 3 times 3 times x. And the decomposed state of 50 is 2 times 5 times 5. Now, what's common on the left side and the right side of this minus sign? Let's look at it. Oh, we have 2. 2 is common. You have a 2 here and have a 2 here. Is there anything that's common on both sides? Let me put a partition here so you can see what I'm talking about. All right, so let's say we have a partition here. Is there anything else that's common? Nothing else is common, right? So we can factor that out. This 2 that is common on both sides, we're going to factor it out. All right. So when we factor out the 2, it's as though we're dividing. Okay, when you're factoring out a term, you're dividing by that term. So we factor out that 2. Okay, and then what are we left with? So if we divide by 2, when we factor out the 2, it's as though we're dividing this by 2 and dividing this whole term by 2. That common factor is taken out, right? And you're left with 3 times x minus 5 times 5. Okay, multiply that all together, the terms in the parentheses. Now we have 9x squared minus 25. So we factored out the GCF, which is 2, from this quadratic binomial, and we're left with 9x squared minus 25. Now, what do you notice about these two terms? They are both perfect squares. So whenever you are given a problem where you want to factor the difference of squares, of perfect squares, you use the difference of squares formula. Okay, so what is the difference of squares formula? Well, let's write that down. The formula is, if you have a square minus b square, the factored state is going to be the sum and the difference of the squares of the term that are being of the terms that are being subtracted from each other. Okay. All right. So in this particular case, 9x squared minus 25. What is a and what is b? Well, we have to start with the left side of the equation. We need to identify a squared and b squared first. So the first term is a squared. Why? Because 9 is a square and x squared is a square. And then 25 is b squared. So based on that, can you tell what a and b are? Let's go ahead and work that out. So if a squared is 9x squared, then to get a by itself, we have to use the inverse of square, right? Which is square root. So we're going to square root that, square root, and then that will give us what? Well, that give us a is the square root of 9, 3 times the square root of x squared, which is x. All right. And then the second term, b squared, is 25. So what is b? You just take the square root of both terms, right? Square root. B is 5. Okay. So now we're going to just put in, following the formula, a squared minus b squared is the same thing as a plus b. I don't have to put the parentheses there. A plus b times a minus b. Okay, we already know what our a's and b's are. Now don't forget the GCF we factored out earlier. So that 2, we bring it down. And then we have a plus b, which is 3x plus 5, times a minus b, which is 3x minus 5. Bam. Ladies and gentlemen, there goes our answer to question number 6. Let's see which one matches this answer right here. Which option matches this answer? So let's see. The answer is option number 3. Bam. Okay, so remember though that multiplication commutes. So a times b is the same thing as b times a. All right. So the order in which you write the product of these factors does not really matter. Okay. So here you have 3x minus 5 times 3x plus 5. That's the same thing as 3x plus 5 times 3x minus 5. So don't let the order of these factors throw you off, because the commutative property of multiplication helps us to see that the order doesn't really matter. Okay? All right. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel. Tons of support resources can be found at Mathgotserved.com. Do check it out, or take a look in the links in the description below. If you have any questions about the questions we just did, you can specify it in the comment section below, and I will be glad to support you. Thanks again for watching, and we'll see you in the next video. Goodbye.